everyone, it's Norm from Tested, and I am in a really awesome place right now. This is the office of Skydio, and this is Adam Brea, co-founder of Skydio. Skydio is one of my favorite products last year, the R1 autonomous drone you guys put out, and 18 months later, you guys have put out now the Skydio 2. That's this guy right here.
Yeah.
Tell me about Skydio 2 and how it differs from the R1. Obviously, visually looks different, but it seems to be a completely new drone here.
Yeah, so we're building on the same technology foundation, and it's very much a part of the same product vision, but every aspect of the product is improved. So we've rolled in all of our customer feedback, everything we've learned in the development of R1, and there's a bunch of new breakthroughs that make this product possible. So we can talk about a few of those. The obvious visual difference is that it doesn't have the perimeter structure around the outside. So the thing that enables that is that we've gone to these high-resolution fisheye navigation cameras on the interior of the drone. So we have 3 on top. I can grab this here, and we have 3 on bottom. So each of these has a 200-degree field of view. 3 on top see everything in the top hemisphere. The 3 on the bottom see everything in the bottom hemisphere. And that enables us to build a real-time, high-resolution 3D map of the environment without needing the perimeter structure around the outside.
And that was one of the big secret sauces of the R1, was that you had 13 cameras on this, and on the frame you could tell these stereo pairs that then, like your eyes, kind of create a depth map of the world. Then with your software creates a virtual map of the environment that it's flying through at, for this one, 25 miles per hour.
Yeah, exactly. So we're using a lot of the same core ideas and core tech, but the software is also second generation. So we've made a bunch of breakthroughs, in particular leveraging deep learning through more of the stack. So one of the really tricky pieces of this is that rather than using conventional stereo pairs, so in R1 we have these cameras arranged in nice stereo pairs where they're perfectly lined up. Here we have rolling shutter fisheye cameras in kind of an arbitrary configuration. And one of the ways that we process that data is all of it goes into a deep neural network that fuses information from all of the cameras together, figures out how things line up, and uses that to build the 3D understanding.
You said arbitrary configuration, so the software, through the data that you've acquired, and you can basically design any type of device, any configuration, as long as there's overlap.
Exactly.
And doesn't need to be, you said they're rolling shutter, they don't even need to be the kind of low-res VGA black and white cameras here that then can create a map.
Yeah, exactly. So we wanted to get onto the way I kind of think about it, we want to be on the cell phone train. Like whatever components are going into cell phones, that's what we want to be using in this drone, because that's the stuff that's really getting optimized and getting better all the time. So these cameras are rolling shutter, kind of standard consumer grade devices, rather than the very specialized computer vision cameras, which means that the performance to cost, to size to weight is just superior to anything else out there. So it's very challenging from an algorithmic standpoint, but it's really powerful if you can figure out how to use that data.
And that's a lot more data. He says it's an order of magnitude more data.
Yeah, exactly. So on R1, if you add up all the cameras, we're looking at about 3 megapixels of visual sensing. On Skydio 2, it's about 45 megapixels of visual sensing. So it's way, way more data coming into the system. And processing all of that is a huge challenge. So we've gone from an NVIDIA TX1 to NVIDIA TX2. It's about twice as much compute horsepower. And then the algorithms are far more advanced. So we're doing a lot of really creative, powerful stuff to intelligently process that data to extract the things that we care about.
And all of that combined really is to give this functionality so that it never crashes, hopefully, right? It is.
Yeah, so I think that not crashing, we think, is should be the starting point
for
drones. Yeah, that's the baseline for drones. I think that drones that crash should really be a thing of the past and something that the people in the future should never have to worry about. But the exciting thing for us is all the extra things that you can do on top of that. Once you have the real-time 3D understanding of the world, you can follow and film people and create amazing kinds of videos. But there's all sorts of other things, especially in the commercial space, of doing real-time inspection, mapping, monitoring, security. So we really think of the autonomy system that we've built as a platform on top of which you can build a bunch of different applications. And sort of cinematic consumer video capture is one thing that we're really excited about. But there's a lot more of that to come. And Skydio 2, we think, enables a lot of exciting stuff in a bunch of different industries.
But what you're surfacing to the consumer first is that awesome autonomous cinematography for people who are, whether they're going on a hike or doing some crazy sport. This really is a hands-free way.
Exactly.
Now we went through and tested the R1. There are definitely things that we felt like we could immediately see the potential. And I'm sure that's something that you and the team here saw the potential of. In terms of its capabilities, what can Skydio 2 do over R1?
Yeah, so I think the way we think about this product, R1 was kind of like the Tesla Roadster. It was the first generation thing. It proved what was possible. It had a very narrow feature set that it was very good at, but it also had a lot of the first generation product trade-offs. It was very expensive, and it wasn't really meant for everybody. With Skydio 2, we've taken the next major step forward. And the product vision here from a content standpoint is it should be like having a professional film crew out there with you, whatever you're doing. We have all the AI and processing to understand the world, create these kinds of interesting, cool cinematic motion. So just in terms of raw performance, we're going from 25 miles an hour to 36 miles an hour, from 16 minutes of flight time to 23 minutes of flight time, from just phone wireless range of 100 meters or so out to 3.5 kilometers if you're flying with the joysticks. So just from a basic spec standpoint, it's a far more capable device. But when you use it, and you guys experience this when you fly it, it's more agile, it's more intelligent, it's looking further into the future. Everything about it is just more advanced, which leads to a better overall customer experience flying it.
That analogy of a film crew is interesting because when I use this, it's a cinematographer, but it's smart enough to do the tasks like motion track, orbit around me, fall in front of me, which is very impressive, but I always wanted to direct it more. And it feels like for Skydio 2, you guys have given capabilities with hardware also to allow you to be more of a director. Can you talk about those features?
Yeah, that's something that we've invested quite a bit in, and the user experience team that we have has done a phenomenal job there. So one of the things that we're really excited about is kind of combining the AI stuff with the sort of cinematic input. So there's a couple of different examples of that. Like one, when it's tracking a person, you can use the joysticks to still control what kind of angle you're getting. So you're kind of like in the director's chair there, specifying the shot. And then we also have things like cable cam, where you can set up two very precise waypoints, and it will keyframe between those two things. And you can even do that while it's looking at a subject. So you can have a mode like tether, where it's constrained to fly on that cable, and it'll go to the closest point on that cable to wherever the subject is, which is sort of like, you can imagine like a sideline cam for a sports game or something.
Right.
And so we've seen ourselves, and we're starting to see this from other folks using the product now, the kind of creative potential that unlocked. Even something that simple done well, just being able to set these 2 points, tell the camera to stay on that line, opens up a lot of exciting stuff. And that's something that you're going to see more from us in the future.
And one of the things that's new about Skydio 2 also, you have a line of accessories, there's a transmitter, two-stick transmitter, but also this thing, the beacon here, that's different than having your phone, doesn't have a screen, but it's more than just an identifier for you. So interesting ways that you can use the point. Well, how does that work?
Yeah, so the beacon is really the perfect accessory for creative control when you're on the go. So through a lot of experience ourselves with the product and feedback from customers, we wanted a way to get sort of really easy control to tell the drone where you want it to be without having to unlock your phone while you're doing stuff. So that's why we created beacons. So you have these nice tactile buttons that you can use to set the shot angle. And then one of the features that we're most excited about we call Magic Wand, where basically you can point at the drone, point to where you want it to go. So it's a gesture-based thing, which is perfect for when you're out there kind of in the wild thinking like, I'd like the camera to be over there. You can just point and get it there. And then it also has high accuracy GPS in it, which gets combined with our standard visual tracking, which means that if it loses visual track of you, it can use the beacon to find its way back. And it also acts as a range extender, so it extends the wireless range out to 1.5 kilometers.
I mean, that's perfect for a director communicating with a film crew using Skydio to say, I literally want it there.
Yeah.
You're just pointing it there, and you can adjust distance and then do your things like the cable cam.
Yeah, it's a pretty fun experience out there flying with the beacon.
That's so cool. I mean, one of the things that's most impressive is the fact that this is 18 months later after releasing R1. I know you guys are a startup and you guys are working fast and have obviously lots of ideas for future products, but tell me how you got from R1 to Skydio 2, because I see 3D printers, I see, you guys are making boards, you guys are manufacturing here, but walk me through this journey.
Yeah, definitely. Even before we launched R1, we were concepting out what we were going to do for our next generation product. And so our first sort of thinking on that is a product that we never shipped. So this is a mock-up that was one of the early concepts for what Skydio 2 would be. So you can see this is actually pretty close to R1. There's a lot of design heritage that carried over. And so this was initially the direction that we were thinking we were going. But the more we got into it, and especially the more that we experienced R1 and kind of thought long-term about where we wanted to go, we decided to go in really a completely different direction. So the electronics and a lot of the early work we did here carried over, but the physical form factor ended up being completely different. So the big change was making the technical bet to go to these interior fisheye cameras rather than needing the cameras around the outside. So we kind of saw enough 18 months ago to make us think that that was going to be challenging but possible. And we essentially bet the company that we'd be able to figure it out. And so we started designing in a completely different direction. So the first prototype that we built was this guy that we affectionately called the Camel, because it's hideous. But
you have wide-angle angled cameras
yeah,
here.
So basically this prototype is all the guts of R1. So it's the same cameras that are in R1. It's the same compute stack in the middle, but it's in the Skydio 2 configuration. So this is the first prototype we did to kind of validate this camera configuration with 3 on top, 3 on bottom. And we're actually reusing the same cameras as in R1. So these aren't full fisheye, which is why we had to angle them forward to simulate the sort of field of view facing forward. And it reused the same battery. It's basically like R1 electronics splatted down in this frame for us to start to get a feel for what it was like to fly that. We also did the 3-axis gimbal.
Which is something that made its way to Skydio 2, and a lot of people wanted that yaw in that camera.
Yeah, exactly. So that was the first sort of prototype in this direction, and then we do a lot of industrial design work and like to make these sort of 3D printed prototypes for us to get a feel, like how does this thing go in and out of a backpack? What's it like to hold it? How do my hands fit with the battery? So there's a lot of early work like that. And then we did some very early flying prototypes. So this is the first thing that flew that kind of resembled anything close to the final look and feel. So with each prototype, we're essentially trying to validate or understand some key risk area of the product. So one of the big changes for Skydio 2 is having the propellers on the front upside down. And one of the things that we really wanted to figure out was what was the landing and takeoff experience there? What happens if the propellers hit the ground? So this, we just flew manually. This never had autonomous flight. It doesn't have cameras on it. We just flew it around manually. And we took it out in every challenging environment we could find and tried to scrape it along the ground and landed on sticks and rocks and things like that. And kind of proved to ourselves that with the battery in the right place and the motors in the right place, we could get pretty robust performance, even in cases of ground contact with the propellers.
And that, in your mind, it still as a company, that is a small percentage of operation time because, again, the baseline is not crashing.
Yeah, exactly. Well, but you always need to land and take off.
Right.
And it's not always the case that you can find a perfectly flat place. So we wanted to make sure that when you land on like rough terrain, and the prop strikes, like nothing disastrous is going to happen.
Yeah.
So that was one of the kind of key challenges. And then the other big one of the major risk points for the product was having the cameras out there on these motor arms, which are vibrating. So the motor is constantly vibrating, which is pushing vibration into these cameras, which adds extra challenge from a computer vision standpoint. And so this is a prototype that we built that has close to the final kind of construction where we have this main metal chassis and then plastic on top and bottom. And so we built this and then we instrumented it with a bunch of sensing out on the arms and ran it through a bunch of different kinds of configurations to measure and understand the vibration characteristics on the arm.
So it's not physical suspension, it is just compensating for and calibrating always in real time.
Exactly. And then this is the first thing that really was like everything integrated together. And this looks remarkably similar to the final product. So this prototype was roughly a year ago. But you can see that like all the major building blocks of where we ended up are there. We ended up deciding, so one of the things you can see here is that we have these little arm extensions on there. So we ended up deciding that we wanted to go to slightly bigger propellers, which reduces the noise a little bit and improves flight time. So the most visible change from this to the final Skydio 2 design was eking the motors out there a little bit. So one of the nice things that we can do here is we can do quick turn prototypes. We have a bunch of machining and 3D printing. So when we want to make a change like that, we can do this and literally like a few hours later be flying the next iteration.
That is so cool. And of course, you not only have a completely new flight system, new motors, new speed controllers, you have a new design for the computer vision, but also the camera is different now. I mean, the whole point is to be able, for at least consumers, to capture great footage.
Yeah, exactly. So we've invested a huge amount in the camera for this product. So we've built up our team in-house, we've built up our lab equipment, we've done a bunch of image quality testing and tuning, and really gotten to a pretty incredible place with this. And there's no one magic thing there. We're using a really nice Sony image sensor. We're using a state-of-the-art image signal processor, which kind of comes from the cell phone world, which is where we think a lot of the best camera technology is developing now. Like the sort of smartphone versus some of the older school cameras. The smartphone just keeps getting better and better. So we're riding that technology wave with what we're doing at Skydio. And there's a lot of things that go into making this work as well as it does. It's really a credit to the team here. And then so we have this vehicle. So this is a final design Skydio 2, but with the top and bottom covers off. So you can see.
Wow, it's a lot of computer hardware.
Yeah. So one of the real challenges here is packing all the sensing and compute we want into such a small package. So if you look inside here, you can see 3 main boards. So the main board is actually mostly hidden. It's down there, but it runs the full length, and that's what has all of the compute on it. So that has the NVIDIA TX2. It has our image signal processor that records the camera data. Basically everything that you need. It's basically like a flying laptop. You can think of that board. And then this board has the power electronics. So this has the speed controllers, does the power distribution from the battery, and this board has the actual recording cards that hold the data. So this card is what records the video data. This is a slot that we use for internal development that has all the logging data. So customer vehicles don't have this populated, but it's in there for us for development purposes.
And subject tracking is still through the video camera. You think of those as separate tracks where the obstacle avoidance and the world mapping is not used for subject.
So it's all pretty integrated, actually. So the data from this camera comes into the main CPU, GPU, the NVIDIA TX2, and is fused with everything else. So you can sort of think of like the 2D appearance-based tracking of where's the person in the image is done here, but the 3D information of how far away are they and how are they moving in the world is done by fusing with other cameras. And that's basically kind of the architecture that we go for. We want to get all of our visual data into one place and then use it as efficiently as we can in different pieces of it for different tasks, depending on what we're trying to do.
Last time when we chatted, you said one of the things that made this work was using machine learning and just large data sets to help recognize and identify things like people. And since the release of R1, software updates have allowed you to let R1 track vehicles, which I'm sure is inherited in Skydio 2, but there's a lot more data, so you have a lot more, the data sets are theoretically bigger. Where do you see this going forward in terms of object recognition, subject recognition, but also just flight capabilities?
Yeah, I mean, there's a lot of exciting stuff to come. So it's very much a software-defined experience. Like, it's all based on autonomy and computer vision, and there's a ton of software flexibility on top of that. So I can't say too much, but one of the things that I would generally say is that we see enormous opportunity to use this same product for commercial applications where you can do inspection and mapping type of tasks and oftentimes keep people out of harm's way, provide situational awareness. And I think that the commercial drone market is something that people have been talking about for a while, and it's slowly kind of starting to work, but we think that full autonomy is really the thing that makes that catch on and scale. Because
that means no direct operator, or maybe a supervisor.
Well, initially, so the way that the current FAA rules are written, you will need an operator to kind of push the big red button if something goes wrong. But the place that we're trying to get to is fully autonomous operation.
And I think take off from a platform, land and charge on a platform, and survey and
just do whatever. I mean, the vision here is that you can deploy as many drones as it takes to accomplish whatever task you want to accomplish. With the push of a button, and it's all done through software. It's the way that you can, maybe a rough analogy is like the way that AWS works today, right? Where you can spin up as many computers as you need for whatever task you're trying to accomplish. and you're sort of abstracted away from all the physical complexity of managing those machines. Like that's what's possible in the fully autonomous drone future.
How do you think about these drones in relationship to each other, having more than one in the sky at once, and awareness of other ones?
Yeah, so I think that's a pretty exciting direction. Like our basic view on that is you need to have one really good autonomous drone before you can have many of them. Because if you can't make one autonomous and intelligent, then if you add more, you're just going to have more problems. But I think we're at a point now where you can start to think about having these things kind of coordinate and perform tasks in parallel.
And for the consumer side, people buying Skydio 2 now, what kind of like software upgrades are you thinking down the line in terms of cinematography tools or subjects?
So I don't want to, I can't give anything away there, but I think you can. The things like the tethered cable cam mode, where we're kind of combining creative control with a lot of the autonomy stuff, I think you can expect that to be a direction that we continue to push on and push out software functionality on Skydio 2 in that direction.
That is so cool. Thank you so much, Adam, for walking us through all this. And again, the really impressive part is that, like, again, one of my favorite drones ever to fly, but the fact that you guys have a new one out, that it's a whole generation different. Less than 2 years later is really cool. Skydio 2 is out now?
So we're shipping now. You can reserve them at Skydio.com. We are behind on supply, unfortunately, for the demand that we're seeing, but we're doing everything that we can to accelerate and build these things as quickly as possible and get them out there into customers' hands.
Sounds like a good problem to have.
Yeah.
All right. Thank you so much.
All right.
Good to see you again.
Thank you.